In this video, let's look at inverse trig functions, right? And yeah, don't worry, you're on the right spot, right? The section 7.1, the inverses, right? And before we tackle that, and look at some of the like inverse notation, like it sort of looks like sine to the -1, right? But that's called inverse sine. And another way to note that is putting an arc in front of it. So I could also have said arc sine, right? Arc sine of 1/2, or I could have said arc cosine of -√3/2. So that terminology is interchangeable. If you see arc tan, then you could say inverse tan. The same thing. But what it does is it goes backwards. It asks you to find the angle who has that particular ratio, right? Find me the angle who has a sine ratio of 1/2. Find me the angle who has a cosine ratio of -√3/2. And so the issue or the problem that we have to be careful of is really is mirrored in algebra when we see this problem right here. And so there was a reason why that was there in the start, right? There's a difference in those two equations, and the difference is based on what is the principal root versus introducing a square root. Only one of these equations has one answer, the other one has two answers. And so this equation here, because the square root's already there, what that's telling you is that it wants the principal root. The answer there is just 5. Okay, there's no ambiguity. Is it positive? Is it negative? It's just 5 when the square root is already defined. Now, if I have to introduce the square root to solve this, that's when you pick up a plus or minus 5. And the reason actually is because of the even power of the square and the even index of your square root. The square root of x squared is technically defined to be the absolute value of x. So it's the absolute value of x is 5, and then we could say that's plus or minus 5. But not that we're going to spend too much time with the algebra. But my point is that because there was a square root, we knew that it was the principal root. It just wants the first one. And that's what we have to define up here when we talk about these inverse trig functions. I want to know, well, what's the principal? What is the one answer to avoid ambiguity? What angle are we talking about, right? What angle gives me the sine of 1/2? Because if I don't somehow define it to be a principal angle, with that, there's an infinite number of answers, right? Here's an angle whose sine is equal to 1/2. I can make that theta right there. That's a 30-degree angle. But guess what? So is this over here. If I go 150 degrees, which is a 30-degree reference angle, that's also a ratio of 1/2. Or if I go all the way around and then end up at 390 degrees, that's sine ratio is equal to 1/2. So I'm going to have to define what we're going to call the principal angles, the principal solutions to these inverse trig functions. And so that's why I have sort of like the geography of the inverse trig functions, because it's going to tell us where should we draw these triangles, so there is no ambiguity. So the ratios will be defined in these quadrants based on the trig function and based on whether that trig function is positive or negative. So in quadrant 1, the good news is that anything that's positive will go there. So if you have a arc sine of a positive ratio, or arc cosine of a positive ratio, or arc tangent of a positive ratio, or arc cosecant of a positive ratio, or arc secant of a positive ratio, or arc cotangent of a positive ratio. You will draw those triangles and label label what your ratio is, and your theta will be an acute angle, be between 0 and 90 or 0 and pi over 2. That will be the principal root or the principal angle when you have a positive ratio. And remember, I'm saying the word arc, and remember, I could also think of like inverse sine, like if I see that notation, or inverse cosine, right? So all of the positive ratios will be put in quadrant 1. Now, we know with trig that sometimes your ratios could be negative. And so if your ratio is a negative fraction, we're going to split up the trig functions into either quadrant 2 or quadrant 4 based on the behavior of that function. So when your ratio is negative and your cosine, arc cosine of a negative ratio, when your ratio is negative and your secant, and when your ratio is negative and your cotangent, we're going to put you in quadrant 2. And so again, thinking about, in standard position, you start here. So when you go over to quadrant 2 to draw your angle, realize it's going to be obtuse. Even though that's your reference angle, it's going to be an obtuse angle. So it's going to be between, between 90 and 180, or 90 and or pi over 2 and pi, I should say. Now, if you are the other three, so if you are arc sine of a negative ratio, or arc cosecant of a negative ratio, or arc tangent of a negative ratio, you'll be down here in quadrant 4. But what you have to be careful of is, again, still drawing from standard position, you actually end up being negative. So these values down here, you would have them as a negative angle. And the reason that it's going to be a negative angle is because those three functions, so when we're looking at arc sine and arc cosecant and arc tangent, we want a continuous range of values for these angles. And so that continuous range of values ends up being, I guess we'll go blue here. It ends up being from negative 90 or negative pi over 2 up to positive pi over 2. So for those yellow ones that were highlighted there, your angles would be from negative pi over 2 is less than or equal to theta is less than or equal to positive pi over 2, where they're defined. Like, I know some of these aren't defined at the quadrantal values, and I get that. But anytime you've got sine, cos, secant, or tangent, your answers need to be between negative 90 and positive 90, or negative pi over 2 and positive pi over 2. And the thing is, really, there's no, unless it tells you which format to give your angle, you could give radians or degrees. It does not matter. Okay. Now, and to get the other functions, the ones that are in quadrant 2 as well as quadrant 1, so like arc cosine, arc secant, arc secant, and then arc cotangent. So those, again, we want to have a continuous range of angles, and so the continuous range is a little bit more natural to go from 0 to pi, or 0 to 180. So for those, we could say 0 is less than or equal to theta is less than or equal to pi, or 0 is less than or equal to theta is less than or equal to 180 degrees. So, I'm going to ask you, know your geography, know where to draw the triangles to create these ratios to answer the questions. So that's what I mean by the geography. Everything positive goes in quadrant 1. Every positive ratio, so that's nice. The negative ratios, they get split. So you need to know which functions go in quadrant 2 and which functions go in quadrant 4. Hopefully you realize that nothing is in quadrant 3. So at no time will you be drawing triangles there. So that's how knowing that is going to help us avoid any ambiguity when we start going and answering these questions. So now going back down to example, A, it says, inverse sine of 1/2. Give me the angle whose sine ratio is 1/2. That's another way to think about that. Find me the principal angle whose sine ratio is 1/2. So here's how I would draw this. It's a positive ratio. So every single trig function, when it's a positive ratio, gets drawn in quadrant 1. So I would draw a quadrant 1 angle whose sine ratio 1 to 2. That's the angle I'm looking for. And by Pythagorean theorem, I know that's root 3. And so if it's any calculation that's done without a calculator, they should be nice values. So, I recognize that. 1 to root 3, the side opposite is opposite that. 1 would be a 30-degree angle, or pi over 6. So it doesn't tell me which format, so either would be fine. And I realize that there are more angles out there that might have that sine ratio, but when it's printed, when it's given, I want the inverse, and it's part of the problem, then it wants the principal one. Just like the square root wanted the principal root, so there's only one value. Okay, so the next one, inverse cosine. Another way that we can think about that is arc cosine, right? And so, drawing that triangle. Okay, so draw me a triangle of arc cosine negative. So I already know it's going to be in quadrant 2, so it's going to be an obtuse angle, and cosine is adjacent over hypotenuse. So then I know that again by Pythagorean theorem, or just knowing that triangle, that's a 1. So thinking about like this theta, even though it's like a reference angle, that's like a 30-degree reference angle. The big angle outside here is 150 degrees, or 5 pi over 6. So either way, I would accept that angle, but it's just that one, right? Not any other place on the unit circle other than just that one. Okay, I want to come down to D for a second here, and look at arc tangent of -1 over root 3. And again, I could think of that as inverse tangent, same function, right? It's asking for the angle whose tangent ratio is -1 to 3. Now, tangent, when it's negative, you draw that in quadrant 4. And so I want to draw an opposite over an adjacent piece. So opposite over adjacent, hypotenuse would be 2. That's your theta. And remember that when we label things, down here, it's going to be a negative answer. So that's -30 degrees, or negative pi over 6. So even though other angles might have that same tangent ratio, the principal one would be -30, or negative pi over 6. Okay, I'm still going to circle back up to C eventually, but I also want to look at E next. Arc cotangent or inverse cotangent of -1. Arc cotangent or inverse cotangent of -1. So again, thinking about where does cotangent get drawn when you're negative. Cotangent is going to be over here in quadrant 2 when it's negative. And again, you just have to know that geography. So I'm back up here. Oh yes, look at there it is. Arc cotangent negative, perfect. So that's the tough piece, or the learning in this topic, is where are you going to draw that particular angle. Now cotangent is a ratio of adjacent over opposite, so it's like a -1 to 1 ratio, and that would be root 2. So that's a 45-degree reference angle. But remember, the angle that's our answer is this obtuse one. So that would be 135 degrees, or 3 pi over 4. Okay. And maybe let's arrow down maybe to one more -1. Okay. So let's go down here to J, inverse tangent of -1. So again, going back to the fact that this is a negative ratio. So the fact that that's a negative ratio, tangent's negative in quadrant 4, it's a -1 to 1 ratio, so -1 to 1, so root 2. So it's the same triangle that we had up in part E, but remember, this angle is going in that direction. It's a negative value. So it's going to be negative pi over 4, or negative 45 degrees. Okay, so that's, again, a good start for the inverse functions. So what I want you to try is the other examples, and then we'll take a look and see how you do, after you've completed the rest.